right next, we have Nick Alexander from Fuel Labs. Thank you so much for coming.
That's actually my middle name. No, it's fine. I use it like across just to kind of make sure that people can't always email me or whatever. All right. How long do I have again? 15? Okay. All right. I'll try to make it. Try to make it quick. Okay. So yeah, for this presentation, I'm just going to present some ideas and as well present what I'm working on, which is called Fuel. So to start, so a little bit about me. I'm Nick. Alexander Dodson. Yeah, there's actually another middle name as well, but I'll never reveal it. Yeah, I've been working with Ethereum for a very long time. I started in crypto in 2013, initially doing a lot of mining in my basement. And I'm Canadian, so I was using cold air to cool mining rigs, and I was heating my basement with the mining rigs, and then tried to evolve out of that to write some early apps on Bitcoin. The Bitcoiners kicked me out of their world, and then I found Ethereum, and then started to work on a very early Ethereum, building apps and infrastructure and stuff like that. Basically, I worked with Consensus for quite a few years, like 4 years. So that's where I met Stefan and Gnosis and all this great group, and wrote a bunch of libraries, did a bunch of things, but now I'm working on scaling DevX and UX for blockchains, which is encapsulated in Fuel. So the main sort of vision of Fuel is quite simple, which is just that we build systems that are there for you when your governments and corporations are not, and really this is about providing human beings more autonomy and more control over their lives as they we enter this unknown phase of humanity where we really don't know how things are going to play out. So the more control the individual has, maybe the better society. And blockchain being a sort of mechanism for us to get there is particularly important from an ethical perspective. And so this is really the vision of the whole project. The mission for Fuel is also pretty simple, which is that blockchains, they don't feel like blockchains. So the biggest problem blockchain has is that it sucks to use as a human being. And it sucked forever. And it sucks because on multiple levels, from both the user all the way down to the way that it works from a security standpoint or from a fundamental standpoint, the entire stack makes it such that a normal human being interacting with it is both extremely afraid and uncertain about what they're using, and this stems from just the way that the entire system is constructed. So with Fuel, you want to ask how are we solving all these issues? And so there's kind of three core things that we're working on. So this is like the how. So one is scale, one is developer experience, and one is user experience. And so on the scaling side, how we kind of fix a lot of these issues that we see with blockchains is we use a few different models and paradigms that we sort of either come up with or that have come up in the space. So the first one is modularism, the second one is the Fuel VM, and the third one is UTXOs. And so to start it off, modularism. So basically in the blockchain space, there's a movement of modular blockchains, which is effectively just coming and stemming from the idea that we can separate concerns of how blockchains work. So instead of doing this one monolithic chain that does everything, you you do a chain that just does a few things. And when you do this, the scaling properties are really, really nice. You get a lot more compute available to do a lot more things. And so in the case of modular blockchains, you're separating execution from consensus, and this really gives you a huge advantage in terms of just processing and total scale. It allows you to get a really nice system where you can basically keep adding computers and keep getting full horizontal scale over time. But you have to separate out the execution. And Fuel is an execution layer that would sit on top of something like this. Now, it can also sit on top of something like Ethereum, and it can sit on top of many different systems. And we'll get to that in a second. The second thing is the virtual machine architecture. So Fuel has its own called the Fuel VM. And basically it will allow you to achieve the same things of typical virtual machines you see in the space. So SUI, Solana, the EVM, all of these different VMs that you typically see, or different chains. But it's been redesigned for a resource-constrained environment where basically we sort of know over this long period of time now what blockchain VMs should be and how they should work, and all the different kinds of constraints that you have to work with. The Fuel VM is excellent in many different respects because it gets you to achieve the same things as, say, Ethereum, but at a far reduced execution cost. There's a lot less execution to achieve the same behaviors. And then as well, there's a lot of other nice things we did, such as basically redesigning the transaction models and stuff like that, and that comes into UTXOs, where you're able to get all this kind of fantastic processing, which means cheaper transactions, but you can also do things like really great light clients between different blockchains, so different deployments of Fuel. And light clients are actually really, really essential for doing really good bridges between these different environments. So bridging liquidity and assets between all these different systems. So I can go into the Fuel VM later, but the UTXOs are also really, really important. So I can go into all sorts of crazy shit about UTXOs, but I'll just stop and say that the core things that UTXOs give you versus the accounts model, which is what Ethereum uses or many other blockchains use, is that you get really nice properties of parallel processing, which is again this idea that you can process transactions over many cores of your computer or potentially over many computers. And parallel processing is really, really important to get the kind of scale that you want out of a blockchain. And as well, autonomy, which is really just that each UTXO becomes like a little payload, but it's not bonded to anything else in the system. So in terms of processing and just how that would affect the system, you get really, really nice properties for scale and efficiency, and also ownership. So someone or a thing can own that little package that's floating around in the system. And again, that comes with a lot of nice properties. So scaling Ethereum with Fuel would kind of look something like this, where you have Fuel at the execution layer, and then you would have settlement, consensus, and data availability being taken by Ethereum. So Fuel really offers Ethereum a few key things. Parallel transaction execution, and not just parallel transaction execution, but really good parallel transaction execution. So not wasted on the EVM's bloat and all that sort of stuff, but really, really efficient. Second thing is optimized for low cost and efficient fraud proofs. So everything we did was optimized for fraud proving. And then as well, maximum security through trust minimized light clients. So the whole system's designed for light clients, which again, they don't matter when you're just on Ethereum, but they do matter when you're deploying thousands of chains and you want them all to talk with each other. And then that's when a light client is really, really important. And then of course, Ethereum comes with a lot of different nice properties of security, etc. So Fuel is really flexible in what it can do. So it can exist in many different configurations. It can be its own monolithic chain. It can be an execution layer, execution and settlement, a bunch of different configurations. Celestia is one of the more prominent modular blockchains, and so it can interoperate with that too. So that's scale. On the developer experience side, Fuel has, we have our own language that we're building called Sway. And this is a blockchain-focused modular DSL, which will target the Fuel VM, but it'll also target other blockchains as well. So we'll also include things like the EVM or MineVM or a bunch of different systems. The idea behind Sway is that Solidity sucks, and Rust is a systems language, and most languages are not really going to cut it between giving you a Rust-like experience, but being something that's built for blockchains. So we're going through the pain of building our own language because ultimately, if we can just put enough work in, we can just get it right, you'll have the same kind of targeted feeling of Solidity, but you'll have the sort of clarity and design of Rust, which really is sort of what you want, I think, for a blockchain in general. And it'll be modular, so you'll be able to put in your own security passes, etc. Fork is a tool chain that is sort of all in one. So it includes everything under the sun. that you need to, build a full app, and you won't need to leave it. And as well, all of our tooling, our language, our virtual machine, all the way down to the fraud proving system or execution is all vertically integrated. So we build everything in-house versus having the community do it, so that we can basically get a certain kind of experience from it. This means it's slower to do it, but ultimately over time we'll be able to build probably a better experience than what you're typically getting in the community. So Sway looks very much like Rust, but instead of having to annotate everything in Rust, you have some really nice systems for things like storage or ABI, and just a lot of things that come out of the box in terms of security checks and passes. Things like reentrancy prevention is done at the compiler level, so it's really safe. And then again, it will target multiple blockchains. Right now, just the Fuel VM. Fork. I wish I had a better shot of Fork, but it is just a command line. It's not really much to look at. And then as well, Fuel is really building not just these things, but is also building sort of a whole platform for reconceiving what a Web3 app actually is. So we've seen the graph and sort of the success of the graph, which is really just a system to contextualize what's happening in a blockchain. But with indexing, we actually see indexing as sort of the back end of a Web3 app. And so indexing is like sort of first class and provided out of the box as well. And there'll be services and things to host that. There'll be ways to open source that and standardize that. But the indexing portion of an app becomes sort of the back end. There'll be standardization out of the box so that when you're visualizing what's happening to the user, everything runs through good standards. So you have a feeling of clarity and safety as a user, and not sort of like, what is this hex address? Why am I signing this? Who is this? Or what is this? Has anyone looked at this? Am I being phished? Et cetera, et cetera. So preventing that out of the box is really, really important. And then everything you need is sort of in one place. So unlike Ethereum, where it's this sort of open garden of all sorts of different apps, we are allowing fully permissionless app development, but in a closed garden, because closed gardens feel better than open gardens, because you can tailor the garden, And so again, it always ends up like this anyway. Use a wallet or use the Gnosis safe. There's already a predefined set of apps anyway, so we're already doing this. It's just we're bringing that really to the fold for every application. So the result of this is that the whole system will feel very much like the sort of Vercel or Apple of blockchain, because it's all been redone from the ground up. On the user experience side, we have native level account abstraction. So no mempool, fancy pants games or different things, tag-ons and band-aids that you see with the EVM. It's at the native level, and then as well scripts. So you can do things like approve and transfer from in one transaction, one flow, which ends up being really, really handy when you're building pretty much anything with tokens. And there's all cost efficiency. Because everything has been redesigned, there's a lot less state usage, so there's a lot lighter cost for the user in general. So efficiency is going to be really key. As well, because of the way the Fuel VM works, each contract can emit its own kind of color token. And that color token will be at the native level. So when you're moving that around and processing that, it's really, really light. You don't need the concept of ERC20 contracts, because there's all this sort of open access to the UTXO level of the system in general. So all of that filters into cost efficiency. So the result of doing all of these things in this way is that you have a blockchain that doesn't feel like a blockchain and a no crypto experience. So you can really only get this when you really, really rebuild it all. And you can try to do this with the EVM, and it will sort of work, it'll sort of scale, and it will sort of make sense. But when you redo it all and you ignore backwards compatibility, because everyone else is working on the EVM, so they can go do that, then we can just work on this stuff. And if we do it correctly and do it right, you'll be able to create an experience for people that sort of blends in with their normal lives and doesn't feel it doesn't feel horrible to use. So you really need to do all of that. So where are we at now as a project? So we released the beta 3 test network. Currently we have around 65 people We have 30 projects building with us. Sway is 419 stars. We're trying to get to mainnet in Q3. And then as well, we're talking with Stefan and other people about some ways that we can work with Gnosis. So hopefully that works out. Yeah, so that's sort of where we're at now, and that's sort of the end of the presentation. Yeah.
Awesome. Well, thank you very much. I'll ask a quick question about I'm curious about the security of the network. Like, do you have nodes that run it? Does it inherit some security of Ethereum? Yeah. Kind of like that aspect of Fuel.
Yeah. So the idea behind Fuel is that Fuel launched the very first rollup, Fuel v1, which I basically built in JavaScript and assembly. JavaScript was a huge mistake, and never write anything JavaScript again. And then assembly was fun, but also really tedious, and that was because I don't like Solidity. But Fuel v1 is the only rollup ever deployed that's actually permissionless with no multisig, with ways to jam transaction past the system. Of course, it seems like no one in Ethereum really cares about security because there's not a lot of transactions on it. But we did launch the actual first and only trustless sort of fraud provable optimistic rollup. So we want to carry that through all of this architecture as well. So with Fuel right now, what you'll have is we'll ship it iteratively, similar to Optimism. So you'll get a bridge, probably with a multisig and a DA committee first, and you'll be able to tap into the Fuel VM. Then we'll select the DA layer, which will be a process, and then we'll add fraud proving in after. And with the fraud proving, while the Fuel VM is fraud provable in terms of its design, we might use an interpreted layer like a RISC-V layer or something like that, and play an IVG similar to Optimism. So there would be probably a set of validators who are running those computations. There's a block producing group of sequencers, and then as well you have light client users, which in Fuel's case, because of the way the light client is constructed, we should be able to have normal people be able to run light clients, and that's sort of the whole point. And so from a security perspective, we hope to achieve all of the security properties that we're sort of looking for. Ideally, I'd love to launch it without a multi-sig, and then the upgrades you have to migrate everything over. But that's just the purist in me that it's not realistic. But that's definitely something that I'd like to see eventually. And then you'll be able to eventually configure Fuel rollups the way you want. So right now we have a BSL license over the Fuel core, which will last to the end of 2024. So hopefully we can sort of build up some network effect on one of our layers. But then after that point, anyone will be able to deploy Fuel rollups, and you'll be able to pick your fraud proving layer, your settlement layer, all that sort of stuff. And again, everything will be in-house and vertically integrated. So it's not like we're relying on anyone else to do that. But that's sort of the security options, if that makes sense. Yeah. So IVG with validators, etc. Yeah. Cool.
Any other questions? Otherwise, we won't keep you hanging from the beers and I think pizza as well. Yeah, awesome. Thank you very much.